Now that we've solved the system using the substitution technique, let's solve it again using the elimination technique to check our answers and see an alternative approach. All right? Let's rewrite our simplified system, which is 16x minus 5y equals to negative 40. And the second equation is 2x minus y equals to 12. And we'll use the elimination technique to solve it. The goal of elimination is to make the coefficients of either x or y opposites, so that when we add these two equations together, that variable cancels out. Now let's see how we can make it work. So let's look at the y terms in these two equations. So we have negative 5y in the first equation and negative y in the second. If we multiply the entire second equation by negative 5, then you can expect we're going to have a positive 5y here, which is the opposite of negative 5y, right? So when we add equation 1 and equation 2, the y variable will cancel out. So let's multiply negative 5 to equation 2. So we have negative 5 multiplied by 2x minus y equals to 12 multiplied by negative 5. So we distribute negative 5 to each term in this bracket. And negative 5 multiplied by 2x is negative 10x. And negative 5 multiplied by negative y is positive 5y. And it equals to 12 multiplied by negative 5 is negative 60. Okay, so this is our new second equation. Now let's write the equation 1 here. This is our equation 1. So if we add equation 1 and the new equation 2, on the left side, we're going to have minus 10x plus 5y. This is from the new equation 2. Then plus 16x minus 5y. This is from equation 1. And then it equals to negative 60 plus negative 40. Now you see the 5y minus 5y is 0. So we cancel out the variable y. Now we have negative 10x plus 16x equals to negative 60 plus negative 40. So negative 10x plus 16x is 6x, and negative 60 plus negative 40 is negative 100. So again, we divide 6 on both sides. We get x equals to negative 100 over 6. Again, we can simplify this by dividing 2 from both numerator and denominator. And eventually we get x equals to negative 50 over 3. And this confirms the value of x we found with the substitution method. They have exactly the same value. Now let's try to find the value of y. We can substitute the x value back into either equation 1 or equation 2. Now let's use equation 2, which is simpler. Originally, the equation 2 is 2x minus y equals to 12. So we can replace this x as negative 50 over 3, then minus y equals 12. Again, 2 multiplied by this fraction, we have negative 100 over 3, then minus y equals to 12. To isolate y, we can add 100 over 3 on both sides. So this 2 becomes 0. Then we have negative y equals to 12 can be written as 36 over 3. So it shares the same denominator of 3 with 100 over 3. And then we can combine them as 136 over 3. So eventually we have y equals to negative 136 over 3. And there you have the value of y. So by using this elimination technique, we got the same results. So x is negative 50 over 3, and y is negative 136 over 3. So both the substitution and elimination techniques give us the same solution.